at this point, I'm sure you're asking yourself, why in the world would you use completing the square? It takes so much longer than just factoring and solving. I'm sure that's what you're thinking. And you're right, because completing the square is, oh my goodness, so much longer. But there are situations where you're going to have a quadratic that you cannot factor and you are asked to solve. And completing the square, Aiden, will work always and forever. Now, what we're going to do is we're going to take a look at a far more complicated problem. And I'll tell you right now, we're not going to have a nice and easy and pretty answer. It's not going to happen. It's going to be some heinous decimal if you were to multiply it out, and it's going to have, or it's going to have square roots if we do simplest radical form. Okay? This one cannot be done through factoring. Let's take a look at Aiden. So, is it possible that 3x squared is a perfect square? No, it's not a perfect square, is it? Or is any part of it a perfect square? Yeah, the x squared is a perfect square, but 3 is not a perfect square. So we need, in order to have a square binomial, we must have a perfect square as the quadratic term, and we must have a perfect square as the constant term. So what can I do? What can I do to manipulate this equation so that that x squared does not have the 3 in front of it? We need to get rid of it. What? Divide by 3. So I'm going to divide everything by 3 first. This is all part of trying to get a quadratic term that is a perfect square. Now 3x squared divided by 3 is? X squared. 4x divided by 3 is going to be just positive 4/3 x minus 1/3. And this is going to equal 0. And I'm sure you're going to tell me right now that this is starting to look worse because it has fractions, but it's not really that bad. It's not really that bad. We're going to have lots of fractions, and that's just the way it goes. So we still are not able to factor that trinomial. So to complete the square, we need to end up with that plus blank. So what am I going to do to both sides so that I have room to add something that is a perfect square? I'm going to add 1/3 to both sides. So plus 1/3 plus 1/3. So negative 1/3 plus 1/3 is 0. So I get my blank. I still have my x squared plus 4/3 x, and this is all equal to 1/3. Now, we're going to have fractions. Don't freak out. It's okay. Fractions are real and they need love too. The process doesn't change even when you have fractions. So what am I going to do with the coefficient for the linear term so that I can find what I need to add to make this a square binomial? What am I going to do with it? All right. Here. I'm going to divide it by 2. So I have 4/3 divided by 2. And someone very astutely said, well, that's just the same thing as saying 4/3 times 1/2. So what is 4/3 times 1/2? 2/3. It is 2/3. For those people who didn't make that jump quite yet, that would be 4/6, which is equal to 2/3. All right. So I know that in my binomial, my square binomial, I'm going to have my x. It's going to be a plus because the linear term is positive. What is going to be the other piece to my binomial? 2/3. Because it will always happen that once you divide it by 2, this is going to...
Why is it cubed? Why is it cubed?
Yeah.
Oh, it should be squared. I'm sorry. Sorry. The process doesn't change. The process doesn't change. I was looking at the third and thinking 3. I'm sorry. So, but we're not done with this piece. We still haven't figured out what we're adding to this blank here. So what will I have to do with 2/3? So I'll have to square it. So 2/3 squared, that's not 8, by the way, that is squared. 2/3 squared is equal to?
4 9s.
So what will I have to add in that blank?
4 9s.
If I add 4 9s to the left, what do I have to do to the right?
Add 4 9s.
So we've already factored this trinomial very well. That's really not too hard of a problem to do. What is 1/3 plus 4 9ths? 7 9ths. Now this problem looks like something that you've been doing over the last couple days. We have a binomial that is squared. It's equal to a number, and we're being asked to solve for the variable. So what will I have to do to both sides so that I can extricate, for Aiden, the x? It's not yet. All right. So what will we do, sir? We're going to square root it. What you do to the left side, you must do to the right. So on the left side, what will I be left with?
X plus 2/3.
Is equal to,
Plus or minus the square root of 7.
and this is where the plus or minus comes in, because as soon as you square root it, that's when you have the plus or minus. So we have the square root of 7 over 3. Okay. So now we have, now what do we have to do to get the x by itself? Subtract 2/3. So we subtract 2/3.
No, wait, you need to put it in top.
I will in a second. I will do that in a moment. I'm going to subtract 2/3. And so I will be left with negative 2/3 plus or minus square root of 7 over 3. Now this is when we're going to have to take the leap into the negative and positive worlds. So I'm going to clear off this side of the board so that we have room to solve this problem here. No, we're not done yet.
Not yet.
Because I would hate to leave math fun on the board not done for you.
It's not right.
So here we go. So we have negative 2/3 plus or minus square root of 7 over 3. So in our positive world, we will have negative 2 plus negative 2 over 3 plus square root of 7 over 3. In our negative land, we will have negative 2 minus square root of 7. And both of them are over 3. So when you are adding and subtracting fractions, what must be true? Their denominators have to be the same. Are their denominators the same?
Yes.
Yes, thank goodness they are, or else we'd have to do conversion, which will happen. So don't be freaked out when it does. So we have negative 2 plus the square root of 7 over 3. Can I do anything else with that?
No, you cannot.
No. On the other side, I have negative 2 minus the square root of 7 over 3.
Those are two answers.
So here's one answer. Here's a second answer. It would have been slightly easier for me to write the answer as this. I could have written 2 plus or minus the square root of 7 over 3. That would work also. But wait, there's still more. In the belief that we should be thorough, let's also find the decimal approximation for these answers. It's not too hard. That's when you pull out your calculator. So we need to know what the square root of 7 is. So we go 7 square root. And this is the positive. So then I'm going to add to it -2. Adding -2 is the same as subtracting 2, right? So I'm going to subtract 2. So one of the decimal equivalent answers will be 0.646.
Wait, what about divide by 3?
But then we have to divide by 3. So we divide by 3. And so we get as one of the final answers 0.215. As the other, in the negative world, we also have to find the decimal equivalent for that one. So again, we will do the square root of 7. This time it is negative. So we hit the plus or minus key on the calculator. And now we are going to go 2 more in the negative. So subtract 2. And then we will have to divide by 3. And so our other final answer is negative 1.549. And I'm rounding to the nearest thousandth. You can decide where you're going to round to. All right.